For topic 3, we're going to actually use the double angle formula. So we're going to do an example with sine, cosine, and then again with tangent, okay? So for example 5, it says if cosine theta equals negative 2/5, and we know that theta is somewhere between pi and 3 pi over 2. So that's just secret. Whoops, let me delete that. That is just secretly saying quadrant 3. Okay, so we have that cosine of theta equals negative 2/5. We know that theta is somewhere between pi and 3 pi over 2, or it's in quadrant 3. Find the exact value of the following. Okay, well, let's think about this real quick. So if we have sine of 2 theta, we need to remember our formulas first and foremost, but we also have to build this relationship between this angle theta, whatever it is, and the ratio of sides that we're given for cosine, okay? So let's not get ahead of ourselves. We're eventually going to get to that point where we use the formulas, okay? But for now, let's just go ahead and build our triangle. Let's build this relationship that we know exists between the adjacent side and the hypotenuse and this angle theta, okay? So I know that my angle theta lives in quadrant 3. We were told that flat out. So let's go ahead and start building. So we know we have some angle theta, so we're going to build our reference triangle, okay? So we'll say this is our angle theta, okay? We know that we have the ratio of negative 2/5, okay? For now, we're going to say that r, the hypotenuse, is going to be positive. It's pretty much always going to be our positive. So if you remember, cosine is equal to the adjacent side over the hypotenuse. So this denominator of 5, we're going to call it the hypotenuse. And the side adjacent to theta, the way we've built this triangle in quadrant 3, that tells me this side right here is negative 2. So let's go ahead and build the other side of this triangle using the Pythagorean theorem, because we know we're going to need sines and cosines in these formulas. Okay, so we need to figure out a relationship for sine. All right, so I know that c squared equals a squared plus b squared. That's just the regular old Pythagorean theorem. Okay, so c in this case is 5, a is negative 2. We want to figure out what b is. Well, 5 squared is 25. Negative 2 squared is 4. All right, so we so far have 25 equals 4 plus b squared. Let's go ahead and subtract 4 from both sides. That's going to give me 21 equals b squared. And I need to go ahead and take the square root of both sides. So I get that b is equal to the square root of 21. Okay, technically it's plus or minus the square root of 21. And we do need to be mindful of that plus or minus, because if I'm in quadrant 3, this value right here for y is going to be negative. Okay, so this is going to be negative square root 21. So be really careful with your signs there. Okay, so now just looking at this angle theta, we know that sine of theta is the opposite side over the hypotenuse. So the side opposite of theta is negative square root 21, and the hypotenuse is 5. Okay, and we already knew, we were given that cosine of theta was negative 2/5, so we don't really have to do any work there. Okay, so build that relationship first. A lot of times you have to build these right triangles in whatever quadrant that the angle is going to live, and then you can build those relationships for whatever trig functions you're looking for. Okay, now sine of 2 theta. What was sine of 2 theta? So you have to either go back earlier in your worksheet, or you've memorized it because you're that good. Just depends on the person. But I'm here to remind you that sine of 2 theta is equal to 2 times sine theta times cosine theta. All right, so 2 times sine theta times cosine theta, that is your double angle formula for sine. So all we have to do is fill those values in for sine of theta and cosine of theta. So this is going to equal 2 times sine of theta, but we know that sine of theta is negative square root 21 over 5. And we're going to multiply that by cosine of theta, which is negative 2/5. And if it helps you, this 2 right here, you can put it over 1 if it's easier for you to see that. Whatever is fine. So let's multiply across. So I get 2 times negative square root 21 times negative 2. Well, the two negatives are going to become a positive. And then 2 times 2 is 4 times the square root of 21. And then for my denominators, I have 1 times 5, which is 25. So Sine of 2 theta is 4 square root 21 over 25. So that's it. So the hardest part is building this relationship, remembering that you have to sometimes draw these angles and then draw the reference triangle, find your missing sides, be very mindful of the signs of those missing sides, and then you've got it. You just have to find your sine and cosine for these. Okay? Now for part B, we have find cosine of 2 theta. Now, you can use any of the three formulas that the double angle formulas for cosine. So just as a quick reminder, we have that cosine of 2 theta equals cosine squared theta minus sine squared theta. So that is one of the two formulas. We also had that cosine of 2 theta was equal to 1 minus 2 times sine squared theta. And finally, we had cosine of 2 theta was equal to 2 cosine squared theta minus 1. Okay, so those were the three formulas that we have that were the double angle formulas for cosine. And you could truthfully use any of those. But let's say that we didn't want to build that triangle, like we didn't have to find sine of 2 theta, so we didn't really need sine. We wouldn't have even had to build the triangle if we were just looking for the double angle formula for cosine because of this one right here. This one right here just takes into account cosine. So if we weren't asked part A, where we had to find sine of 2 theta, we wouldn't have had to do that much work because we already know what cosine of theta is. So let's say for this one, we're going to use 2 times cosine squared theta minus 1. Well, 2 is just 2. And then cosine squared theta, well, I know what cosine of theta is. That's negative 2/5. And then we just have to square that and then subtract 1. And that's going to give us our value for cosine of 2 theta. Okay? So let's see what we get here. Well, 2 I can write as 2 over 1 if you like that. Negative 2/5 squared, we want to square both pieces. Now remember, if you square a negative, it becomes positive. And then 2 squared is 4. 5 squared is 25. And then I need to subtract 1, but let's think about this. How can I write 1? So it is a fraction with a denominator of 25. Okay. I know that when I take 2 over 1 times 4 over 25, I just get 8 over 25. And then I need to subtract 1, but I'm going to need it to be in fraction form. So all I would have to do is write 1 as 25 over 25. 25 over 25 has a value of 1, but it's in a format that works for us a little bit better. So let's clean this up. 2 times 4 is 8. 1 times 25 is 25. We need to subtract 25 over 25, which is 1. And when I do that, 8 minus 25 is negative 17 over 25. All right, so when you subtract fractions, remember you subtract your numerators, you keep your denominator. 8 minus 25 is negative 17, and then that's just going to be over the common denominator of 25. Okay, so that is the double angle formula for sine and cosine. Let's look at an example with tangent. Okay, so example 6 says, let theta be an angle such that tangent of theta equals 3/4. Okay? And then it says, use the double angle formula to find tangent of 2 theta. Well, ordinarily, we would want to build these angles. We would figure out where our angle is, what quadrant it lived in. We would build some kind of reference triangle. We would find missing sides. But let's first, before we get into all of that, let's remind ourselves what the formula for tangent of 2 theta is. Okay? So we know from earlier, the previous video, we found that tangent of 2 theta was equal to 2 times tangent of theta all over 1 minus tangent squared theta. So I don't really need to build any kind of a triangle here because I don't need to know any of the other trig functions. I don't need to know what sine or cosine are because they're not part of this formula. I already know what tangent is, so I'm good. So all we want to do is take this exact formula that I've written down, but anywhere we see a theta, plug in a 3/4 because we know that, well, not anywhere we see a theta, anywhere we see a tangent of theta, plug in 3/4 because we know tangent of theta is equal to 3/4. Okay, so I get 2 times tangent of theta. Well, tangent of theta is 3/4 all over 1 minus tangent of theta squared. So tangent of theta is 3/4, and if I square it, I just get 3/4 squared. So we got to do a little bit of work here. So in my numerator, I get 2 times 3/4, which is going to be, you could write it a couple of ways. You could say, okay, well, I have 2 over 1 times 3 over 4. I can say 2 goes into 4 twice, so I get 3 over 2. Or you could say, okay, I have 2 over 1 times 3 over 4, which is 6 over 4, and then you could reduce it and get 3 halves. Any of those would work. But either way, your numerator is going to be 3 halves. And then your denominator, we're going to start with 1 minus. And then 3/4 squared, we want to square each part of that fraction. So 3 squared is 9, 4 squared is 16, and we need to do a little work. So the question I would ask you is, how could I write 1 as a fraction with 16 as the denominator? I need to do a little bit of work in my denominator here. I need to figure out what 1 minus 9/16 is. So I need to find a way to rewrite that 1 in fraction form with 16 as the denominator. So for now, the 3 halves in the numerator is going to stay 3 halves. The 1 in the denominator, I'm going to write it as 16 over 16. And now I can subtract 9 over 16. So my numerator is still 3 halves. My denominator, I can now subtract those numerators. So I can subtract these numerators right here, 16 minus 9. So that's going to be what, 7 over 16? So that's really 3 halves divided by 7/16. Hopefully you remember how to divide fractions. The first one stays the same. And you multiply by the reciprocal of the second one. So let's see, this 2 divides into this 16 8 times. So we should get 24/7. All right, and that's it. So that's the double angle formula. We've seen an example with cosine and sine, and then another example with tangent, okay? So in the next video, what we'll do is we'll start to build those half angle formulas. So we've looked at the double angle formulas. Next up is the half angle.